for me particularly, um, I have a heavy software engineering background, so I work a little closer with the developers. SRE deliberately tries to get people from diverse backgrounds in the sense that they recruit software engineers, they recruit people with distributed systems backgrounds, they recruit systems engineers, people in an ideal world, if you have uh, something like um, search or Facebook where user experience is very homogeneous and you can just deploy like a fraction of traffic to that, like that can almost be your tests, right? If you know that like a failed search isn't going to, if you're a cloud database and suddenly your write fails, and you just lost the important piece of data or a credit card transaction, that's obviously like not.
To the deprecation of the old one. So what's your approach on that?
Yeah, that's interesting. So one thing at Google I found, and now we're going to get to like a very limited view of Google, and I can, and so people may say from other teams, "Oh, you're totally wrong." But from my approach, what I've seen is there's just such a large footprint for like the networking services because they have to operate in every single cluster or data center.
Developing in the professional way.
Sure. Yeah, I mean, one thing that I've really gotten a lot of mileage from has been doing deep dives on topics. I spent a long time contributing to an open source library called Scholars. Really smart people commenting and telling you, "Oh, you did this little thing wrong," or "This isn't wrong, but we actually want to make this more similar to other things." So I think open source, contributing open source, is a great way to learn because um, you know it's kind of like the joke of like if you ask a question on the internet, no one responds, but if you tell people something, everyone will correct you, um, right? Like so, if you want to get feedback and exercise a little bit, so I don't fall apart sitting at a desk all day long. Um, uh, I think I would say that better than reading books on software engineering is reading good software.
So you saw the sneak peek of today's episode. My name is Maciej Sekora, and I have honor to introduce our today's guest, Vincent Marquez, who is a senior SRE at Google. He loves tech, big data, and functional programming. He has a heavy software engineering background, including contributions to open source projects such as Scala or Apache Beam. And now let's dive into today's episode. What's the typical day of life as SRE in Google?
Yeah, sure. So I think one thing that I've learned when I joined Google was SRE doesn't necessarily have a typical day because um, SRE deliberately tries to get people from diverse backgrounds in the sense that they recruit software engineers, they recruit people with distributed systems backgrounds, they recruit systems engineers, people who are very good at understanding um, Linux systems or CI/CD pipelines, and kind of depending on your strength will basically mean what kind of work you kind of will gravitate to. All SREs will do things like on call and incident mitigation, and all SREs will do some programming, and all SREs will do some operations work to some degree. But um, you know, because people have different backgrounds and are all joining SRE, um, some people focus more on the CI/CD type work. Other people will really be software engineers working on platform type projects, and some will be um, doing more systems engineering and performance tuning and analysis, and others will be working with the developers who are shipping features to ensure that the features are done in a way that's reliable and can scale at the right level that Google needs. So all of that is like a typical SRE day, and for me particularly, um, I have a heavy software engineering background, so I work a little closer with the developers um, and work on um, kind of the distributed system aspect of it, of how can we fail systems reliably. That's something that I'm particularly interested in, is the failure scenarios of how do we have automatic failover, how do we ensure that when systems fail, they fail properly.
Yeah, I understand. Like I saw that you have quite heavy like software engineering background, so you quite shifted to SRE, let's say lately in that long road there. So maybe if you could tell how you would compare the SRE approach at Google and your team to other companies that you have experience or you heard about.
Yeah, I mean, part of the difference is just Google's scale. I mean, even knowing, about Google and the reputation they had before I joined, I still underestimated kind of the scale of things they operate at. So, I mean, it's just interesting to see that, like, even a small system that, maybe collects one particular metric, can have such a large scale that it's a challenging project, and you have to think about, like, well, what about deploying this worldwide, and how do you deal with things like data center failure, or power failure, or disasters, where some companies just don't think about that. They say, all right, well, I'm going to put it in the cloud, Amazon will deal with that. Well, in our case, we are the cloud, so all these small changes can have like ripple effects across the entire system. So there's definitely a lot more thought for things that what seem simple, and are often simple in other companies, are less simple than they appear at Google. So that's kind of the big difference that I noticed, was this kind of scale that they're operating at.
So you mean, let's say you obviously have to be somewhat detailed approach before, like a software engineer, but at Google, you say that being more detailed and looking at small things, it's even more important than it was before.
Yeah, I mean, I think I don't mean that other developers at other companies don't have challenges. It's just you have to think of a couple extra things, like I said, deploying your software to every continent, and hundreds of cities, uh, is a different challenge than necessarily even at Verizon. So that was a company I worked at before, which is a fairly large company, and it had quite a large service footprint. We used Amazon there, and it wasn't quite something we had to worry about, which was like failure. How a data center failure would impact us, because it was as simple as kind of saying, like, oh, we're going to deploy our software to 2 availability zones. Um, Whereas it's not quite as simple at Google when we're deploying to hundreds of data centers. At least for my team. Other teams maybe don't have that issue. There are teams at Google who kind of operate more as a traditional development team. Um, I would be more on the infrastructure side.
Mhm. Yeah, that nicely leads to other section that I wanted to cover. I wanted to ask you about the deployment. Let's say if you can describe who is responsible for the deployment in the team, if these are the developers, or it's more in the role is separated, that you have like specialized SREs, and the developers they develop the code and are, let's say, a lot less responsible for the deployment and these things.
So the answer is kind of, it depends. Um, for for the large systems that lots of developers are working on, usually they will partner with an SRE team to work together on the deployment aspect of it. Ultimately, SRE is responsible for production health. So there's kind of an engineered both collaboration and tension there of the SREs wanting to make sure that the velocity is not too much to impact health in a negative way, and the developers want to ship features because that's what customers are asking for. So it's kind of the loose demarcation, but it is kind of a joint effort of where uh, usually SREs will help more on that just because they have more expertise on developing deployment systems, customizing deployment systems. But that's part is shared ownership, and then you have the infrastructure tools like monitoring or automatic failover systems that are applications that SREs write, um, and those are kind of owned by the SRE software teams, um, and almost like another development team. So it kind of depends on the application. In that sense, Google just has different setups depending on what the tool is doing and if it's a customer facing tool or not.
Yeah, and your work particularly, or your team, it's mainly for customer facing or some internal
Right.
tooling.
Yes. So I'm supporting the cloud networking. So it is a customer facing tool in the sense that it does affect all the customers using Google Cloud. Um, but we have our team also has our own other infrastructure to support that. So some of the infrastructure is run by us and developed by us, and then some of it is collaborated with this very large development team that are kind of expert network and C++ programmers working on this network application to deploy to Google Cloud.
Mhm. Yeah, and you mentioned the AWS cloud provider, and I'm interested. What's your take on the cost management? If you, let's say, what's your approach if you separate that on service or project, and what's your take basically on monitoring that cost management?
Yeah, I don't have, I don't want to speak as from a position of major authority. So if people have other uh, better sources, go for it. But I really think it kind of depends on where you are in kind of the life cycle of a company when they're approaching cloud. I mean, cloud's so amazing for growth, right? I mean, it's so nice not to have to like think about provisioning. I mean, that's like a pain, right? Having to think like, let me do like capacity planning, um, let me do growth, let me provision for load spikes, right? Years ago when I was you know much younger, I worked for a company that uh, made software for car dealerships, and the the car dealership company um, actually ran an ad on I think it might have been one of the big football games, maybe even Super Bowl. And so their traffic was like 50 times um, what it normally was going going to this national car brand. And like there's no way like that makes sense to provision for a one-off like sales event that you're going to do. We had to go to the cloud, even though they were traditionally like a more traditional company that was like, oh, can we just like buy computers? So anytime you have that kind of elasticity and load and demand, I think you just you understand that the price is going to be high from the cloud, but you're presumably it's not as high as the money you're making from your services. Um, uh, you know, as soon as you get to a certain scale, then you can start making like trade-offs. Like I know Dropbox like moved some of the storage off cloud and saved hundreds of millions of dollars. But you know, Dropbox is also top tier company with top tier engineers and has the ability to spend 2 years coming up with a data center solution. Um, so I've worked on systems that were like on-prem. I worked on hybrid, and I worked on cloud, and now I work on the cloud, and it's complicated, but definitely depends on like where you are in the life cycle, in my opinion.
Okay, I understand. And as you mentioned, the deployment, could you walk us through the process, if it's possible to tell, if you are launching, let's say, new service, that what is the process behind that?
Sure. I mean, I think I can say that probably the most important thing is having good monitoring. Um, Google has very good tooling, but open source stuff is getting better, and there's some proprietary tools too that are on par with Google tooling. Deployment stages happen. You have the normal dev deployment, staging deployment, and then production is a whole thing too, because we respect availability zones in the sense that we don't make deployments that could bring down your system, uh, right? So if you are have your systems operating in different um, zones, you're safe from it reduces the blast radius of the deployment, right? Um, that's done on purpose. So there are different there's a slow deployment that happens, being careful to make sure the blast radius never takes out like the system. As these things as the application is deploying, there's constant checking and monitoring each time like systems are updated. Like when I say systems, what I mean is like a unit of work, like a single like a virtual machine, so to speak, um, of the application are updated. There's testing and monitoring to see if anything changed, the health of the service changed, um, and if at any time something looks, you know, like it doesn't, like the health has suffered compared to how it was previously, then the deployment is like often halted, and there may or may not be an alert that fires depending on what happens, and SREs or developers, depending on who's around, will definitely take a look and see, was this a false positive? Um, was this an error that was always there that we just found, or is this the new deployment breaking something? So there's a lot of thought and monitoring that goes into just making sure a single deployment both proceeds slow enough to not impact customers, and then also monitored enough to where we can notice any performance issues or degradation or anything like that. And then eventually it will roll out to the world, and everyone will have the new version of software.
Mhm. Yeah, in the monitoring and like deployment, do you have, let's say, some methodology? I heard about that some companies have, let's say, target group of customers that let's say have discounts and are more tolerant to some mistake or little outages of the system. Do you have some methodology like that to, let's say, first go to some specialized group of customers?
Um, Not customers, but internal projects is would be the thing. So we have internal tools that are like non-critical, right? Like these might be things like extra data collection, or reports or something, or um, toy projects that are experimenting with new things. Those are often the guinea pigs, right? So we would break our own internal non-critical tooling before we break customers. So that's kind of the same philosophy, but they're not paying customers. They're Google employees that are the guinea pigs, so to speak.
Mhm. Yeah, and could you elaborate more? You mentioned the incident management and that you have quite detailed approach to monitoring in Google in general. So could you tell me more about how you manage that incidents and also the post-mortem analysis of that?
Sure. Yeah. So incident management is tricky, and this is something that probably, in my experience, Google is very advanced at. In that, right away, it's important to give people who are on call and handling incident critical data, um, which means there's been a lot of thought and tooling that's gone into not just saying, hey, there's a problem, but to say, here's the problem, here's why it was alerting you, here's the historical graphs of what this has done, um, and here's some links right away to see more details and to see logs about this. For instance, like a typical alert might be higher latency, right? Like maybe a customer doesn't notice yet, but suddenly there's higher latency in a particular data center, right? Um, and you get an alert. There's graphs to show historical latency, so you can see how much of an outlier is this been a slow growing thing, or is this been a fast growing thing? There's usually a link to show you if there's an ongoing deployment. Um, there's easy ways to find if another team has been deploying software. Sometimes um, another team or a new Linux kernel goes out to everyone, and you have to figure out, oh, maybe that has like some weird bug in it that slows things down. So being able to click quickly from an email or like a message uh, to get into some of these graphs, um, and to get into the logs, to click to the source. I mean, there's links to here's the source code that is maybe related to this, to be able to quickly see, is this a one-off thing? Is this a blip because of customer behavior did something crazy, or is do we need to take action right away before the rest of the system gets worse? Yeah. So having all that, like it takes quite a bit of investment. Which is probably why other companies don't quite have as advanced a tooling, but there's definitely made handling incidents uh, easier to know just how bad an incident it is. This is also important for communicating to customers to be able to say, hey, there's an incident in one single data center. There's some excess latency. You'll see latency, but if you move your traffic away from there, it'll be fine. Versus, hey, like here's an incident that is across the whole country, um, or this actually happened only for 10 minutes. We're sorry you had a problem, but it's not an incident any longer. So all of that helps with customer communication as well, which is important when you're a cloud provider or something like that.
Yeah, and obviously, like there is the new there are the new tools coming, like using the AI. Do you have, for example, as you speak about the incidents, you described how you analyze the past incidents, but let's say about if we move to real-time incidents, are there any new like tools that you particularly found useful in that field? That, for example, I heard about some elastic feature that analyzes logs in real time and tell you about incident maybe even before it happens, or some. Do you have some take on that?
No, I think that's stuff like under development, so I won't say much on that. I don't have a lot of experience in it, and I don't want to get into hearsay or anything like that. So I'll just say no, not yet. But hopefully soon. There'll be some cool stuff to share. I can come back if I have more data soon.
Yeah, I was just curious because like I'm also experiencing like these tools in other areas, let's say code interpretation or generation documentation. So I was curious if it's your in your basically your
No,
field.
I haven't done too much. I mean, I do quite like the code generation for learning new languages. I mean, one thing at Google, there's quite a number of different languages. So Golang is new to me, but I definitely can say that Bard has helped me learn Golang. It is a good way to learn a new language, right? Because you could kind of frame, um, what you want to do in another language, and it's pretty accurate for translation. Like I'm not sure if I'm confident enough in it to like have me write code from scratch or from comments. But if you write some Python code and say, please translate this to Go or to Java, it's pretty good at that, and that's kind of a fun way to learn a new language or learn a new library is kind of have it do that. So that has been my recent experience with LLMs and something that I've used at work.
Yeah, we have similar experience. I was playing with some JavaScript code, which I didn't have experience, so I used that for that. But back to our main topic, I wanted to ask you about the testing and, let's say, quality insurance. I think you touched that, but what testing strategies do you implement to ensure reliability? Or you can mention the type of tests you prefer, or which type of tests are, let's say, must have for you, and which are just complementary and you do that during the time.
Sure. So I'll gonna get probably philosophical after a little bit here because I have lots of opinions. So at Google, I don't think about tests too much because there's actually a team called EngProd that works with the developers. That is a team that comes up with tooling to write automated testing and automated testing frameworks and load testing. Um, and that's kind of outside of the boundary of SRE in the sense that, I want there to be good tests, but I also uh, am less worried about uh, correctness of any given feature and more worried about, system-wide outages, right? Like there's too many features for me to worry about like every single one being correct. What I'm focused on is making sure like the system doesn't break for everyone in a given data center, or even for a percentage. Or I don't want 20% of all customers to be broken. Um, so so testing for me in that sense is less about correctness and more about failure strategy, right? Like how do we mitigate broken things, um, which is different than other jobs I've worked at. As you know, at Verizon, I was like a lead on a particular project where we had to make sure all of the logic worked as well. So testing was a big thing for me there. So in terms of what I prefer for testing, um, I I like a combination of unit tests and end-to-end tests. I think ultimately unit tests are there for developers to increase velocity. I mean, like it shortens that feedback loop of like finding bugs quickly and being able to iterate. Um, and you know, in an ideal world, if you have uh, something like um, search or Facebook where user experience is very homogeneous, and you can just deploy like a fraction of traffic to that. Like that can almost be your tests, right? If you know that like a failed search isn't going to ruin someone's day or cause an outage, they're just going to hit reload again. Um, that can almost be your end-to-end test. Uh, if you're a cloud database and suddenly your write fails, and you just lost the important piece of data or a credit card transaction, that's obviously like not an acceptable way to do testing. But I think in the same philosophy, that's where you can get like artificial traffic or end-to-end testing as a way to kind of replicate that the spirit of this. Like let's have real traffic go to this, and let's use monitoring and rollback strategies and all that to kind of expose flaws and handle this, because ultimately that's kind of the dream, is just like write code, passes unit tests, should be in prod very soon. It's not that simple, but that we can dream about that, or maybe if you work on the search team, maybe it works for them, but not for our team. But that's always the goal is to like move forward kind of that um, very strict unit test, and let's ship it as soon as we can, and trust our tooling to mitigate that damage of any possible bugs to being as small as possible.
Mhm. Yeah, I understand. Uh, Also to the testing and quality assurance, could you tell how you manage the dependencies in if you make changes to some service that you don't break the other one. I heard like from some companies that they when they approach that similarly when having let's say public API, so they don't change the endpoint, but for example just add some new one and then do the deprecation of the old one. So what's your approach on that?
Yeah, that's interesting. So one thing at Google I found, and now we're going to get to like a very limited view of Google, and I can and so people may say from other teams, "Oh, you're totally wrong." Um, but from my approach, what I've seen is there's just such a large footprint for like the networking services because they have to operate in every single cluster or data center that you have to make everything backwards compatible all the time, right? Like so there's very little worrying about versions of things because like things take forever to die in terms of like versions of the APIs. So that is a different kind of approach that I've seen at other companies that um, if you're able to deploy things quicker and kill features faster, um, then you can have service registries and say this service needs to have this upstream service has this API. And I've seen cool systems like that, but I haven't seen that at Google. And I think that's just because our application is a little unique in that it's such a large footprint across so many data centers. So yeah, but I'd be curious to know if other teams at Google have different experiences or other large companies. I mean, ideally, yeah. I mean, uh, I haven't given it too much thought, but I could see like in a dream world of you could have some bar like across APIs, right? Like I was saying, like this needs to use this one, and there'd be some sort of like you can't check a compile time, but you could check it like deployment time of like validation for which APIs are on which versions. Uh, but yeah, I'm not sure. I wish I hadn't had more to say about that. It's an interesting question though.
Yeah, thank you. So other part I wanted to ask, as you are experienced SRE, so what maybe some advice to younger SREs? What would you tell them, or maybe something you didn't know at the start, but now as you have the experience, you find particularly useful in educating yourself and developing in the professional way?
Sure. Yeah, I mean, one thing that I've really gotten a lot of mileage from has been doing deep dives on topics. I spent a long time contributing to an open source library called ScalaZ, which is a functional programming library in Scala. Um, and I'm not using Scala right now, but being able to kind of really dive into a topic um, like that was really useful. I mean, you start learning how to see things a different way. It's a tool in your toolbox. At another point in my career, I decided to really kind of read some open source and for some of the garbage collectors in the, the common language runtime. And I looked at some of the Java ones too, and kind of writing toy garbage collectors for fun. Um, and that was kind of another thing I spent, like kind of just a year on of like a hobby project. And then that's kind of how I learned a little more about memory management. I mean, you know, for me, like, reading books is important, but having, just picking something to work on and really dive into, and then go on a mailing list and ask people for help and find people who are more experienced than you. really help you do deep dives. I mean, so the fact that I've been able to spend, time understanding kind of more high level programming languages, a little bit of type theory, um, and then also spend time a little bit of low level stuff, understanding memory, understanding caches, understanding threading, how it works lower level. All of that is very helpful in SRE because you have to change context. There's times when I'm looking at threading code in C++, and there's other times when I'm thinking about writing a little bit of Python to collect all these metrics and decide how to fail over a system. Um, and so kind of being able to jump up and down the stack is important. And I think it doesn't necessarily matter what your project you pick, but pick projects that you get to like spend a year really like thinking and digging into and having fun with, and then after a while pick a new project and yeah, that's just been something that I've been able to draw on, and now it's just once you do that, you gain the confidence to be able to jump into new things. Um, then when someone says, "Hey, do you know anything about databases? I need you to become an expert on databases," you say, "Well, I've never done anything with databases, but I know how to become an expert in, you know, JavaScript, and I wrote a compiler for, this other thing." Sure, sure, why not? I'll spend some time reading the books and playing with it.
Yeah, nice you touched that. Like the Databricks will be my daily bread in the next days probably. So I know. And do you have, you mentioned that you explore the side projects to deep dive into some concrete topic, even for a long time, like the year. Do you have some mentors you work on that with, or you're more of exploring?
Um, no, I definitely have had mentors in the Scala community is really active. I also on the database side. So I wrote there's a project called Apache Beam, which is it's Google's open source data processing engine. It's kind of like an API for similar to Spark, if you're familiar with Spark or Flink. So I'm the author of the Cassandra module for Apache Beam, um, which that's another one where I kind of did a deep dive into Cassandra and NoSQL databases and uh, needed to kind of change some code, and I ended up rewriting that. But just the process of submitting a pull request to like a large repository like Apache Beam, has tons of really smart people commenting and telling you, oh, you did this little thing wrong, or this isn't wrong, but we actually want to make this more similar to other things. So I think contributing open source is a great way to learn because um, you know it's kind of like the joke of like if you ask a question on the internet, no one responds, but if you tell people something, everyone will correct you, right? Like so if you want to get feedback on your code, send a pull request to a large project. That's well thought out, and if you're polite and stuff, you'll often get people telling you either what you did wrong or how you could improve it, and that's been a good learning experience for me as well.
So you say for you it's more like natural learning that you, let's say, do pull request, and in the community people will give you feedback. You don't have like the let's say traditional mentoring that you would meet some mentor for 2 times a month or something.
No, I think yeah, it's a little more spending time in the community and chatting and going back and forth with pull requests or in IRC or that kind of thing. So
Mhm. Yeah, so thank you for these interesting thoughts. Maybe beyond of coding, so the listeners can know more about you. Maybe far from the software engineering and the stuff. You have some interesting hobbies or something you find out interesting or spend time lately.
um, let's see. I mean, I have a family now, so I spend time with my son and wife, and um, I try to exercise a little bit so I don't fall apart sitting at a desk all day long. Um, and I sometimes read about software engineering in my free time too because it's interesting. And I read. Um, I guess I read novels. I like fantasy novels, so that sort of thing. But yeah, I guess the majority of it is software engineering and family.
Yeah. And for the reading, you have some favorite author? I mean, for the software engineering education, or maybe some concrete title that you could recommend?
Software engineering. I'm looking at my bookshelf. I think I would say, let's see. I think I like the. Uh, I think I would say that better than reading books on software engineering is reading good software. Um, I really think picking well done open source projects is a good way to go. Um, like I read through Spark. That's a really good project. Um, ScyllaDB. That's another good one that I liked. Um, let's see what else. I've, I'm trying to think of some other ones. I Apache Beam I think is an interesting one to read because that's I'm probably biased there since I worked on it so much. Um, Scala itself, the compiler, is interesting to read. But yeah, the kind of reading software, especially that is out in the open and has been used by millions of people, is a pretty good way to kind of see what works at a scalable architecture. Um, that was definitely one of my recommendations over books if I can twist the question a little bit. So to read code, yeah.
What was that? I didn't catch that.
Oh, I said if I can twist the question a little bit, yeah, I'm going to say instead of reading books about software engineering, definitely read actual code of these popular, well-known projects and see how these scalable projects can come together, being put together by hundreds of people or something like that.
Mhm. Yeah, interesting. So I would wrap this up, and I want to thank you that you took your time and energy to put in that.